Yes.
Yeah. Sudeepa was very interested to know who the external examiner was. Now you know, right?
So, she was not knowing.
No, I'm not
Oh,
supposed to tell
Wait,
the
this is a
student.
confidential information. Oh my
Of
God. Sudeepa, please try to complete in an hour.
Yes, ma'am.
Yes, because Dr. Super Nice are very busy always.
Oh,
The big
yes.
shop,
Yes. I have to go to my daughter's school. There is a PTM.
no? I had class in the morning, so I just finished the class and then in 15 minutes it was interesting.
Saturday you have to teach, huh?
Tuesday, Thursday, if there is a class, then we teach. Otherwise, because the teaching cycles are either Monday, Wednesday, Friday, or Tuesday, Thursday, Saturday.
So, Sudeepa, where are you now?
Ma'am, I am at home only in Bangalore.
No, that's not what she asked.
I am asking about the affiliation. What are you doing now?
Ma'am, I'm teaching in PS University.
Okay, yeah.
Yeah.
I read your article, that Indian Express site, which is published.
Not mine. Not mine.
No, it was an interview, right? And somebody gave an interview.
No. Actually, it was surprising. I did not write the article. I actually had no idea. What happened was, because I after that paper was published, I sent a communication to DST. That was like 3-4 months back. Okay.
But you are one of the authors, right?
Yeah. But DST is actually one who started spreading it around. So I, in fact, had no idea about this news article coming out.
Yeah.
One of my former colleague, Dr. Sudarshan, he first saw it, and then he sent it to me. Sudeepa, you can start.
Okay. Yeah, I think you can start.
Yeah.
It's time. Okay, so I'll just introduce Sudeepa, and then I'll just let her take on the center stage. So Sudeepa is one of the very few students remaining at PS University where I used to work. After her, there is couple of other students who have already, they have already submitted the thesis. But in terms of what we used to do together, she's one step closer to me closing it down altogether. So she's helping me reach the closure because I don't plan to work on cytometrics anymore. So her thesis is on cytometrics with a lot of modeling, but the central hypothesis of her thesis is that, when we look at raw H indices and raw citations, there is a law of preferential attachment, which means, and that was proposed by Barabaki and Albert some time back, and they showed that raw H indices and raw citations, they follow a power law distribution. Okay, what it implies is that after certain critical number, people tend to follow you anyway. So it does not have a direct correlation with the quality of your articles after a certain threshold. Okay, and that's power law distribution. What she showed was that proposing a slightly different variation of the same metric, we can get rid of the power law distribution, and that's the central hypothesis of her thesis. Okay, so I'm very, very pleased that 4.5 years of work have come to a meaningful conclusion, and I will let Sudeepa Roy to take over now.
Thank you, sir, and a very good morning to all of you. I am Sudeepa Roy Dey, and I will be presenting my thesis topic, Epidemiological Model and Genealogy Tree in Measuring Scholastic Influence, a linked study via machine learning. The work has been completed under the guidance of Dr. Snehanshu Saha and Dr. B.S. Dayasagar. So before I go into the details of the work that has been done, these are few of the preliminaries that had to be done before I could come to the stage that I am right now. So I completed my comprehensive viva on 3rd of June 2019, followed it up with seminar 1 and 2 in 2019 and 20 respectively. And then I had my pre-submission colloquium, which was completed on 20th May 2021. I will also talk briefly about the publications that I have done so far. Then we will follow it up with the thesis title, what was the motivation, the problem statement, and what are the proposed outcome, and the models that we have proposed, the ALICE and epidemiological model and epigraphiology.
Sorry to interrupt you. Are you
Yes.
recording this?
Yes, sir. It's
okay,
being
great.
recorded.
Thank you. Yeah, go ahead.
So that's going to be the overview and the agenda. The coursework details are as follows. So I had taken 4 papers: linear algebra, research methodology, advances in web intelligence techniques, advances in knowledge data discovery. And these were the papers that had appeared in the year 2018 and 19 respectively, and following were the grades that were achieved. The publication count so far has been with respect to the journals, quarter 1, quarter 2 journals, there are around 7 publications. With respect to the work that I have done, conference proceedings have been 3, and there have been 2 contributions in terms of book chapters. So these are the publications in quarter 1, quarter 2 journals that have been done so far. As I will be discussing the topics, I will be also relating which publication is for which particular work. So these are just a briefing of all the journal publications, and these are the conference and book chapters that have been prepared and that have been presented as well. These are all published work. So coming to the PhD thesis title. So the title itself suggests that there are 2 models on which I have been working, and one is the epidemiological model and one is a genealogy tree. But both these models we are using to measure scholastic influence. Now, what exactly is scholastic influence? I will be discussing in a short while. But the problem statement here is what we have tried to do is to measure scholastic influence. We have considered 2 models, and these models were used for extracting 2 parameters. So we focused on 2 parameters. One is independence and one is diffusion. Now, scholastic influence so far has been measured by the traditional forms of H-index, I-10, or author impact factors. But as the scientometric community is growing, and with the kind of research, the kind of research community, the evolution that is happening, there is a demand to measure scholastic influence, not just based on pure citation counts or pure publication counts. So we have interleaved the 2 new concepts, that is independence and diffusion. For the parameter of independence, we will be using the genealogy tree and then follow it up with the modeling using CS production function. And the metric that we propose is called ALICE, Author Lineage Independent Score. For the diffusion parameter, we will be using epidemiological model, and here we have done two different kinds of modeling, one at the author level, and here we will be showing how R0, the reproduction number, is efficiently used to create or to predict the diffusion between the different categories of authors. And then epigraphology, which is a hybrid algorithm being proposed, where we will be trying to measure the author influence score. So that's going to be the overall decomposition of the work that has been done. So the outcomes of the dissertation will be as follows. So the complete work, the number one point that we had to work on was to create a citation network and create a genealogy tree. So this was the number one outcome that was done with respect to the kind of parameters we were looking into, especially scientific independence. Then the second important outcome of the dissertation was how we have used the genealogy tree as a backdrop to calculate scientific independence and then use the CS production function and different algorithms, optimization algorithms, to create a unique metric which is called ALICE. Now, ALICE is going to be a metric which will come very handy for research assessments, funding, recruitment decisions, and we will see how this is going to be a major tool in the coming future of research assessment. Then we have also gone ahead and traced the pattern of growth among various authors, and here we will be using epidemiological model, which is again a very important outcome of the dissertation, and epigraphological model, which is further taken at article level. And epigraphology is going to be the unique graph driven diffusion model, which is again going to measure the influential article score in a citation network, where reproduction number will give us one shot prediction of how influential an article is. And all these different metrics and models are going to be very, very crucial in the coming age, where we are trying to find out rising scholars, influential articles, or funding young scientists, and recruiting scientists who have crucial publications but lean citation index, how we can actually go ahead and do this kind of a recruitment, and how we can help them out. That is going to be the crucial outcome with this metric. So if I go into a complete overall work that has been accomplished. So the overall work has been done at 3 levels, but for this particular work, I will be focusing at author level and article level. Since my work is on to the scholastic influence, so I will be focusing purely on the author level and article level. So at author level, we will be working under two parameters, like I told you. One will be the independence matrix, where I will be using the genealogy and the author lineage independence score. And one will be the diffusion model, where I will be using the epidemiological model and epigraphology, which is going to be at the article level, which is the grassroots level. And that's how the entire work has been done. A bit of a work has also been done at the journal level, where a binarization model has been proposed and has been created. But for this thesis, I have focused completely on author level and article level. So let's come to the roadmap for motivation. Now, we all know that suddenly there is a surge in the number of PhD degrees, and people are going ahead and, they are applying, submitting thesis, and it has been noted by UGC that there has been an exponential growth in the number of theses that has been submitted, especially in the scientific domain. The statistics that I'm showing here is of the year 2017-18, and I'm sure the statistics right now will be double the score. On the other hand, the international market is looking towards creating more opportunities for young researchers. The European Research Council, ERC, has started new provisions of funding scientists who are young, and they want to give them funding based on the quality of the work that they have done and whether they have the capability to shoulder a complete scientific project on themselves. And they want a certain matrix and parameters by which they can do this judgment. And the sad part of the entire story is that all of this is still being measured by using the traditional matrix, that is H-index I10. The Roland score says that H-index is nothing but a square root of total citation, and the graph at the right side corner exactly reflects the same. So hence we can say that only with H-index can we do a kind of measurement that we are trying to do. Can we really measure a scholastic influence? And what is H-index at the end of the day? H-index is the number of publications, the number of citations that I receive for the number of publications. So for example, if I have received a H-index of 4, it means I have 4 publications with 4 citations each. Whereas on the other hand, a seasoned celebrity author or an author who has been working or is in the domain of research for a longer period of time will definitely have more publications and more citation counts, but may not have the kind of influence we are looking at. So hence H-index and I10 and all of this, we are not going ahead with the kind of influence we are trying to measure or with the kind of influentiality in terms of only citation counts. So here is where we pitch in our problem statement. We need a much better scholastic influence metric, or we need something which can give us a much better, broader diversity in terms of how we are going to measure a scholar's influence. Another important point is why exactly we need a scholastic influence, or why do we need to measure it? There is no normalization that is done between the different fields. There are some niche areas where there is bound to be less H-index with respect to areas where there is a lot of publication. So how do we map these two scholars from two different domains? Also, how do we see a H-index of an early person, a career of an early scientist with respect to a scientist who is already seasoned? How can we compare the H-index of these two people? And at the end, does citation count, which is just a quant, can we use that to capture the true essence of an author's work, the influentiality that we are talking about, or the quality of the research paper? And also we would like to understand that is a citation count, which is also open to manipulations by self-citations and coercive citations, is it a good parameter to even indicate the influence of an author? So all these questions are slowly giving the scientometric field a new domain where we would like to work and put our project across. Now, there has been a famous quote by Albert Einstein who said, "Not everything that counts can be counted, and not everything that can be counted actually is being counted." So that's what we even try to understand with this kind of an influence that we are trying to do. We are trying to count it, but look at what way we are doing it. So that's where the entire project has been worked upon, and that's where we pitch in our topic. Now, there has been existing literature, and if I have to talk about the existing literature, there has been huge uproar, and there has been a lot of criticisms for H-index, and there have been a lot of work that has been done in the different variations of H-index, and people have been slowly moving with the advent of statistical methods and machine learning techniques that have come into the picture. People have started using a lot of different algorithms to find out a unique way of measuring the impact or influence of an author. And one of the major ways that have come into the picture is through PageRank algorithms or through new variations of the H-index and some different forms of network structure or some diffusion models. But again, we can see that each of these models that will come into the picture, if I try to break it down, this is how the breakdown looks like. So when I was doing the survey on scholastic influence, it was found that basically the work is being found at 3 different levels. There are a lot of papers that were talking about the author level matrix, which are the traditional matrix, and a new version of it, which is the alternative matrix, like the ResearchGate scores and the Altimetric scores. And then on the other hand, there have been some papers which have indicated slightly towards scientific independence, but this is very much restricted to the citation network, the co-authorship network, or the collaboration network. And again, this is again very much with respect to a static network structure. There has also been papers with respect to diffusion of influence, which have taken mathematical models and network structure. But again, the problem here as well comes in terms of when we use the static structure of the graph, how are we putting dynamism into it? We are talking of a static snapshot of a graph of a citation network and applying the mathematical model. Will it actually capture the diffusion or the speed or the impact that it creates? So if we broadly categorize the survey that was done with respect to the work that is done so far in the field that we are working, this was the three categories that we could come up where substantial amount of work has been done. But from these existing definitions of SI, we were able to come up and squeeze out some important pointers. First of all, H-index, I-10, author impact factors, they are heavily reliable on the databases. So for example, if I have H-index, it depends on the database for which for which it is being reflected. So and also H-index is also very, very highly artificially boosted with citation, self-citation counts. It can be boosted. There is no field normalization that happens in H-index. And also H-index is it's said to be little biased towards the seasoned authors, and young publications and young researchers often are at a disadvantage because they have less number of publications. On the other hand, the alternative matrix that has come into the picture, like the ResearchGate scores and all of that, has been found to be completely inconsistent. If I have to take up one case, Peter J case has been come into the picture where the RG score of the scholar has been shown to variate over a period of time. In fact, the citation count comes down. How does the citation count comes down? So there has been a lot of inconsistent intransparency even in the RG scores or the different kinds of alternative matrix that are used. So overall, what we could have understood from the entire problem statement was that though H-index is a powerful and a popular author level matrix, but it is still having a very huge share of drawbacks, and it still doesn't do justice in a lot of situations, especially for authors with lean citation scores, but very powerful work that they have done because they have less number of publications. Then we have also come to the conclusion that yes, graph-based matrix are good enough, especially if you compare it with the existing citation-based matrix, but only with the structure of the graph, the citation graph, it will not capture the behavior properly. So it has to be a multi-level, it has to be done at a multiple level. Third, alternative metrics are good enough, but again, the credibility is uncertain because we have cases where the scores were not in alignment with what it was. And third, the scientific influence, which we are talking of, cannot be just one parameter. It is a multi-layered parameter. It needs to be done with a much more powerful mathematical model and statistical model to give it the support that it requires. So with these observations and learning from the literature survey, we move towards our project. So this was the first thing that had to be done: data acquisition and visualization. Very important point for the model that we wanted to create was how do we acquire the data, and then how are we going to visualize the data. So for this, the data sources that were used were Google Scholars, Web of Science, the Mathematical Genealogy project. If you see on the left hand side is the snapshot of a data set that was downloaded from the American Mathematical Society supported by the Mathematical Genealogy project. The data was very crude, very raw, and had to be processed properly with respect to removing the blank spaces, the hash symbols, and then we converted the data into a JSON structure. This JSON structure was very efficient, and we could see that we are able to get the kind of structure we are looking at, especially in terms of how we would like to see the advisors, the children, the authors, the name, and all of that. Next, we had to see when we wanted to create our first genealogy tree. Now, when we are creating a genealogy tree, we wanted to see the data that is downloaded, is it able to be in the form that we wanted to do? And in genealogy structure, the first model that we proposed, we wanted to see the author, the advisors, and the advisees. So this visualization is again very important. Once the data has been downloaded, we had to convert it into a form so that the visualization becomes clear. So we use the data-driven document D3JS to see whether for each node we are able to get the data that we are looking at. And this was successfully done. We could see the name of the author with the author ID, the ID of the advisor, the name of the advisor, and the children of the particular node. Now, what do you mean by children? So we have in the genealogy tree our successors and our predecessors. So in this case, every author has his or her guide and the supervisor to it. And we have two level down, which are the children and the subchildren, which we term as the advisees. So if you look at this particular structure, this was absolutely captured the way we wanted to. We further did a little more research and we could also visualize the grand advisor and the children to it. So as a result, for this particular author, Colin C. Adams, not only we could see the advisor, we could also see the grand advisor and we could also see the children of it. Now, being it was a huge structure, so I could only present a snapshot of it. So the first important challenge was we could mitigate the challenge that we could get the structure that we wanted to from the downloaded data. But again, with the JSON format that was downloaded, there were few problems that we were facing, especially in terms of the complexity of the JSON structure. And since we had huge amount of data that was downloaded, also with respect to the storage and how are we going to derive the centrality, the network structure from the JSON structure. So definitely there was a cry or there was a need to move from the JSON format to a format which would be easy for us to comprehend. Hence, we started our transition from the JSON format to the Neo4j graph database. Now, the Neo4j graph database was an important point where we could visualize the data in the form we wanted to visualize using the complex cipher queries. So for example, the JSON format that was downloaded, we feed it into the Neo4j graph database. And we started hitting different kinds of queries to see if we could extract the kind of data we wanted to extract. So for example, in this case, we could extract 200 authors and their university mapping. So if you see, the black node is the university and the set of authors who are affiliated. So this was, we could extract informations in this format, author to university mapping. Then for our genealogy, we wanted author to advisor mapping. So even that was available. We could do that with the cipher query. So in the center, we could see that which is the advisor and who are the different advisees. So we could even see that. And we could also do author to university mapping with respect to the advisors. So different complex queries were run and the Neo4j was responding well for us. Now, with the kind of knowledge that was gained and kind of information that we could pick up, this was the right time to create our genealogy tree. So then the first step we did was we created two networks. First, we created a scholastic network, which is the network which contains the articles of an author and who are the citing articles. And second, the author's genealogy relationship. That is the complete relationship between an author, his advisees, advisors. And we created a modeling of the graph database where we focused on each node with respect to the author, the article, the advisor of the author, the institute, and the country. Right? And then we went ahead and merged these two networks and we could create successfully our genealogy tree, which was in the form of this kind of a network. This is just a snapshot. It was a huge network. We could only present as of now. This was the snapshot that I could present. If you see here, the purple nodes are the author nodes and the pink ones are the articles. Two relationships were captured. One was authored by and one is guided by or advised by. So both the relations were captured successfully and we were able to create our genealogy tree, which was the first major step. This work that I just spoke about has been published and this is published in the Journal of Scientific Research, and the paper title is Use of NoSQL Database and Visualization Techniques to Analyze Massive Scholarly Data. Right? So this was the first part. Now comes the second part. Here we use the genealogy tree as the backdrop and we use it to create our first metric, which is Author Lineage Independence Score, or ALICE. This was very, very interesting journey that we had done, because it was something where not only the parameters were computed, but there were a lot of graph structures that were used, data structures that were used to compute each of the parameters. Now, since we wanted to focus on scholastic lineage independence, so the three parameters after a lot of brainstorming was decided as: one, genealogy citation. What do you mean by genealogy citations? Citations which are received by an author from his or her ancestors or predecessors. And this network from which it is being observed or it is being extracted, we call that network as the genealogy network or local network for that author. Next comes the offspring of the genealogy network. That is, when two or more people are having the same guide, they also tend to cite each other frequently. So hence what happens is they tend to become a community within which they are trying to cite each other's work. So we wanted to even capture that citation owing to the common guide and owing to the common, the community network that we had. So we call these researchers as siblings because they had the same parent and they are also sometimes belonging to the same affiliated institute. So we captured these citations using the community citation. This was again an offspring of genealogy citation, and it could easily be captured because we knew who were the advisors and we knew who are the advisees. So the community between those nodes was easily captured. And the third was self-citation. This is when the author tries to his or her work, keeps on citing his or her work a lot of times. So the third parameter was self-citation. Now, the second important part was, once we have decided the parameters, how are we going to now create the network? How are we going to extract these citations? So here we converted the JSON into a block matrix. Block matrix was important because we wanted to capture 2 hops up and 2 hops below. So if you see, for this particular genealogy structure that we have, something on this side of left side, we had to convert it into a block matrix. And here 1, 2, 3, 4 are basically the levels of the hierarchy. So 1 and 2 represent 2 hops below, 3 and 4 represent 2 hops up. So if there is a node which is present 2 hops up or 2 hops below, we indicate it with 1. If it is not present, we indicate it with a 0. This was done for all the authors. At this point of time, we have shown it only for A, B, C, D nodes. Now, next what was done is we created a author citation metric. This is where all the authors are listed and we created a citation matrix based on the citations received by one author from the other author. So if X is citing itself X, so we call that a self-citation. So if you see here, 10 is the self-citation and hence for X, the score was given as 10. The total score from the entire column of X comes as the total citation, which comes to 28. Similarly, for X, we could not find any community. So as a result, the community citation was given as 0 and the genealogy citation was given as 18. Similarly, we did the same process iteratively for all the different nodes that we have come out for that particular genealogy structure. Now, 3 matrices were created: all author matrix, 2 advisor matrix, and advisee matrix. What are these matrices? I will just come down in a second. Now, genealogy structures are pretty complex. They cannot be so simple as we thought. So here is a representation of how we solved a complex genealogy representation. The complete structure sometimes had to be broken down to make it visually and making us understand the complexity in an easier way. There are nodes, for example, where the author will have 2 advisors. For example, the node H has 2 advisors, C and D. So we had to tackle with these nodes by splitting the node into H1 and H2 and shifting the entire load of the advisees to the higher node, that is H2. Then each of the nodes in the network were given a author ID. This was done uniquely to represent the understanding that every author has a unique ID which will be used for searching that author. Two matrices were created, advisor to advisor matrix and advisee matrix. The two advisor matrix had list of all the advisors where there had the two advisors of that particular node. So for example, whichever node has two advisors like H, J, K, those advisor IDs were written in the two advisor matrix. And the other side, we created an advisee matrix where we listed out the advisee IDs of all the authors. And this way we could create two different matrices and we were able to perform the final resolution of cases with genealogy tree. Now there were three important cases that needed to be resolved. First, we wanted to search an author in the genealogy tree. And second, we wanted to see what happens if the author has two advisors, or what happens if the author has repeated same name, or it can be a multiple name case. So these cases had to be resolved. So the first way of doing it was, if you can see the algorithm that was written, let's say I enter my author name as an input. So in the entire author ID, it will start searching for the name occurrence. If the name occurrence occurs at least once, we can say that that particular author is present. But if the name occurrence is equal to 0, that means the author we are trying to search is not present. Now, if the author is present in the genealogy tree, the next thing we need to see is we need to collect and see if that particular author has two advisors. So to do that, we will go ahead and check whether that particular occurrence of the author ID is twice. So if my occurrence has come twice, it indicates that I have two advisors. So immediately my ID will be secluded and put in the two advisor matrix. And the next step which was done was, if I had to extract all the IDs from the two advisors, then that array will tell me that I have an ID which is the ID of the input author. So three arrays were created for that. One was the array 1, where all the IDs which occurred twice was collected, and one was array 2, where all the IDs which occurred once was collected. So if your ID is occurring twice, it means you have two advisor, and hence your matrix will be, you will refer to the matrix two advisor matrix. Whereas if you have only once, it means that either your name is unique, or you may also have a multiple name case which will again be separately tackled, seeing that whether it is a repetition or a redundant value, and accordingly it will be removed. So this is how the four cases of genealogy tree was resolved. The work that I just spoke has been published again in Journal of Scientometric Research, and this was the work that was done as Genealogy Tree, Understanding Academic Lineage of Authors via Algorithmic and Visual Analysis. Now, the next part was, once our genealogy tree is done, we have already computed GC, CC and self-citations. The next important step was computing Alice. Alice is our matrix that we have proposed, and it is one of, I think it is one of the major contributions of this thesis, where we go ahead and perform a author lineage independent scoring model. So how is it being done? So the first step we did was, we have already created the genealogy tree. We have already got all our citations from the different matrices. The next step was to convert those citations into non-genealogy citation, that is 1 minus GC by TC. This was done because we are looking towards author lineage independent score. So if I wanted an author to be lineage independent, the genealogy count should be accordingly converted into non-genealogy citations. Means how many citations beyond his genealogy citation, how many citations beyond his community citations, and how many citations beyond his self citations. This would capture the actual picture. So we converted all those GC, CC and self citations. We derived the lineage independent parameters by using the following formulas as shown in the slide. Now, once the formulas were ready, once the parameters were ready, next is the model. Here comes the CS production function. Now the CS production function that we took is actually a economical, it's a production function model which is used in economics a lot of times. A quick point about what this basically the CS production function has. It has certain parameters, and these parameters were what we were looking at. First of all, there was something called substitution parameter, rho. There was something called the share parameter, which indicated how much is the share of that particular parameter and how much it can be replaced by the other. And also we had to see that this CS production function is homogeneous in nature and it had a constant return to scale. So here the meaning is that it is homogeneous and it is constant return to scale. So if you increase the input parameters by n, the output will also improve by n. Right? So using this CS production function and the parameters that we have, we plugged in our lineage independent parameters OCQ, NGC, NCC, and the share parameters were alpha, beta and gamma. This was calculated by the optimization solver by itself. The value of rho, elasticity of substitution, is again a very important parameter which tells you how much elasticity is given to the model in terms of when you are working with one parameter replacing the other. And here the parameter, the elasticity of substitution was between 0 to 1. The operating conditions of the model is said as, a CS function is said to be concave in nature and it will attain a global maxima when the coefficients are alpha plus beta plus gamma equal to 1. This was an important criteria to be solved, a constraint. But we had to use this because we wanted to attain the global maxima. Also, each of the share parameters should be greater than equal to 0 and the rho value should be again greater than equal to 0. So these were the operating conditions of the model.
Sudeepa, one second.
Yeah.
Sudeepa, sorry to interrupt you again. I mean, you need to hurry up.
Okay, sir. Okay. So I think I'll come to the results of this model then. So the Alice was then, when we started working on this particular model. So here again, Alice, we tried to see if the score is, monotonic, and we were able to get the monotonicity. Again, with respect to the challenges that we faced here is with little change in the value of rho, Alice was changing a lot. So there was a need to show that we wanted a computational challenge to be solved with respect to, again, another optimization that needs to be done at this point. And hence, we went ahead and used the modified PSO. Now, what is a modified PSO here? That is particle swarm optimization. Why is it modified? Because here what we tried to do is we tried to update the velocity of a particle based on the updation made of the local best of the particle. And usually the traditional form of PSO is where we use the particle best. But here we will focus on the local best of the particle, and using that we have done the PSO and applied it on the CS production function. And this time we could see that yes, the score was coming down to an optimum score. And for each of the authors, we have been able to get the perfect score. There were two approaches that were again done. As I told you in the beginning, we wanted to get hold of the normalization part. Authors from different backgrounds cannot have the same score. So we tried to take up two approaches. One was the generic approach and one was the threshold approach. In threshold approach, what we did is areas which are very niche, we tried to take a threshold by taking the average of first 10 authors, the scores of the average of the first 10 authors, and that was converted into a threshold. So anybody who crossed that threshold, we did a minus from that value and that value was shown. If they don't cross the threshold, the value was kept as 1. And then we performed the same Alice on both of it. And as you can see the results for both of this, the ranks and the scores were properly reflected. And you can also, and we also went ahead and did it on a real life project, which is, on a real life data, that is mathematical genealogy project. The same score, the same model was applied on 100 authors extracted from mathematical genealogy project, and we could see the scores as well and the graphs which are in sync with our hypothesis. This was a self-organizing map that was created to see how the different scores are being arranged in a map. So SOM clustering was also done, and it was in sync with our ideology. Okay, now since Alice is a novel metric, there are a lot of questions which will come into the picture. So is it equal to H index? No, the first graph tells it is not equal to H index. Secondly, when we started comparing Alice score with NGC and H index, we could see that Alice and H index and all of these, there is absolutely there is no correlation, and Alice scores was more concentrated towards where there was NGC, NCC, OCQ. It did not have any relation with H index. Now, the next important point, what Sir said in the beginning, is define the preferential attachment. Now, very important point is, do rich get richer? That's what is happening. People who get cited will get more citations. And that is not very correct, because we do not want to go ahead with the same philosophy. If you are visiting a particular, if you are citing somebody, it should be purely because of the work that is being done and not because of the citation counts it has received. So we wanted to check with respect to power law function that whether preferential attachment is there in Alice. And that was one of the major hypotheses that we had proposed in the beginning. And with the graphs that I'm showing on the slide, you can see that both Alice and NGC, NCC, OCQ, they are defying the preferential attachment, which means that if you increase the number of citations, that does not increase your Alice score. If you increase the number of citations, that does not increase your NGC, OCC or NCC scores. They are mostly concentrated towards the independence of the author. So we could capture the independence of an author. Now, this is a post facto analysis that was done between two authors, one with a high score of Alice and one with a low score of Alice. And when we tried to do a co-occurrence keyword mapping, we could see that for an author A3, there are a lot of mapping, lot of co-occurrences of the keyword which were matching with the guide. And whereas for the author A20, who had high Alice scores, you can see only 4 words are matching, which means that this particular author, though has been able to work on very little projects, but has made an own, it has gone beyond its guide's work and has worked on its own and got a independence factor to it, right? So this work has been accepted by Journal of Information Science, Q1 journal, and this has been accepted as Alice, a novel metric in lineage independent evaluation. I'll quickly go into the second part of the parameter, that is the diffusion model. Now, in the diffusion model, why we are exactly taking it up and what exactly we are trying to do here is, diffusion models are used. Often we see that we are trying to take H index of an author who has been in the publication for long and somebody who has just entered or started doing research. How do we compare their H index? There will obviously be a lot of difference. And how do we track their trajectory? So in this case, what we have done is we have used the infection model. And the infection model that we have picked up is the epidemiological model. So what we have done here is, the entire infection model, the SIER model, has been now converted, or we tried to create an analogy between the SIER model and the model that we are trying to show, the author influence diffusion model. And here what we have done is, each of the states are equated to the states like, for example, authors who have published. So all the articles of that author in a published state is susceptible. The moment the author starts getting these citations for the articles, if the citation is within the community. So in this case, we will say that the citations received are like infections. So if the infection is within the body, we say that the article is exposed. But if the infection is received from outside the community, we say that particular article is infected state. And if an article does not receive any citations for the past 3 years, we say it is in the removed state. So we try to create an analogy of the infection model into the epidemiological model. And accordingly, all the parameters were derived using differential equations, as you can see in the slide. And also we have proposed for this model the endemic equilibrium and disease-free equilibrium. Even that is also derived, where we could see that the model does have a disease-free equilibrium and an endemic equilibrium. Once all the equations are in place, Next, we derive the equation for reproduction number. Reproduction number is actually one of the most important determinants which tell you how spread of the disease will happen. So we capture or simulate the same field or same kind of diffusion by using a reproduction number, where we have used the basic reproduction number formula, and in the formula we have derived our for parameters. By putting our parameters, we have derived the equation for it, that is R0 is equal to beta plus alpha plus gamma divided by 3 alpha plus gamma into epsilon plus mu. Once the reproduction number has been derived, all the formulas are in place. Next, what we did is we took the data from Web of Science for the year 2010 to 17, and we derived around there were around 100 authors for whom we calculated the parameters of beta, alpha, gamma, mu, R0, the reproduction number, along with the H index. Now, once the data set was available and once we have calculated and filled up all the parameters, the next step was, how are we going to manage the trajectory? Like we told you, we cannot compare the H index of a new researcher with an old researcher. So in our model, we did 3 bifurcations: rising star, celebrity author, bloated author. Rising stars were those researchers who had fewer publication counts, young researchers in terms of publication. Their H index was also less than 10. Celebrity authors were, on the other hand, those researchers who had high publication count and high infection rate. And bloated authors were those researchers who had high H index, but when we see that their infection rates is high or low, we were surprised to see their infection rate is actually low. So I will show you this in the following graphs. We took the first example. Rising star, young researcher, Sahar J. 9 publications, H index 4. So if you see here, the H index of this particular person is 4. But when you see the infection curve, the young researcher shows amazing infection curve owing to the infected rate that it has created. And you can see the SIER curves that we have simulated and we have seen. Then we take the example of Raj Kumar Bhuiya, highly cited author in the domain of cloud computing. Excellent H index, lot of publications, and it is definitely in fact reflected as well. His infectivity rate is pretty high. H index also is going beyond 65, and when we calculated whether he is epidemic, endemic, and it was seen he is endemic in the terms that no matter how much publications he does, his infection and influence is there already. It will not go away. So he is found to be endemic as well. And the last case was the bloated researcher. Had H index of 58, very good publication count, but when we tried to go into the deeper details of the citations of this person, of this author, it was found that his infection rate is just 0.5. But his H index is 58, so which means it was artificially bloated by different ways of self-citations and manipulations. So we could successfully capture the trajectory of 3 authors in their 3 different age groups and 3 different criterias. And again, we, as Sir said, we would like to see whether our diffusion model follows power law, and we could see the log-log graph when we plotted. We saw that number of papers by an author is not getting affected by the infected papers. There is no relation, and the graph shows it all. Then we did a sensitivity analysis as well. So the sensitivity analysis, because basic reproduction number is such an important parameter, we wanted to do how sensitive this reproduction number is with respect to the variables, the independent variables that we have taken. So here we performed 2 sensitivity and index. One was the partial differential equation method and one was the linear regression method. In partial differential equation method, the parameter which was surprisingly coming into the picture was alpha. What was alpha? The infectivity rate. And another performing parameter which came to our surprise was epsilon, which means how many papers are not getting cited at all. So we could conclude it and back it up even with our model. So we again went ahead and checked it out with our linear regression model. And in the linear regression model also, this same point was reflected. And it was surprising to us to know that not only it is important for authors to get average infection rate as pretty high, but also if your papers don't get cited and if you have a huge chunk of papers which are not getting cited over a period of time, that also brings down your infectivity rate. So that was also another important point that we had found out, and it was interesting to note this work. So this work that I just spoke about in brief has been published in or the Journal of Scientometric Research. Also, this has been a conference paper we had presented in the SIAM Conference of Mathematics of Data Science. Okay, now we come to the last model, which is epigraphiology model.
We
Now,
have
yeah.
the time. I
Okay.
don't think we have the time, so I'll suggest that you wrap up.
Okay, so shall I just show the results for this model?
No, it's okay. I mean, you can just go to the conclusion.
So the model that the final model, I would just like to show these as some of the output that we could get for all of this. Okay, so if I had to, wrap up the entire process of this work and what are the contributions, for sure the thesis does contribute into creating two important metrics, that is ALICE, author lineage independent score, also the mathematical models that we have created in terms of the epidemic models, the epidemiological models in terms of the trajectory that we could see. Also, the last model, which the epigraphology model, it was a hybrid model actually. It was a hybrid approach where we applied the epidemic on a citation network. So we tried to diffuse the influence on a citation network, and we combined two things, that is epidemics on graphics, on graph, and we made a hybrid approach out of it, and we could see the articles which were having lower citations actually had much more, they had the capability of being super spreaders. And each of these models are the ones which are not following, I mean, we do not proclaim that they are going to, I mean, they follow the power law distribution, which again goes with the hypothesis that we started at the beginning of the work, that rich should not get richer. There has to be a breakthrough into it. And also reproduction number, which is a very underestimated parameter, has come out as as one of the heroes of the model of epidemic, where we can use it to create one snapshot influence diffusion across the citation network. So we don't need to create a complete citation network, which is computationally very expensive. So with just calculating reproduction number, we can actually predict the influentiality of an author, of an article as well. So these are some of the major contributions of my work. And at the end of the work, I would like to say that we all are more than our H index. It's just not H index, it's much more to it, to measure the scientific or scholastic influence. So that's about it. Thank you, everybody. If any questions, then I'll take it up.
Yeah, nice, Sudeepa, very nice. So
I'm
I'll just.
sorry, I had to rush in a few slides. I'm sorry for that, but
That's all right. Is there a question from the audience? We will take up the questions from the audience. Then I would respectfully ask them, if they don't have any questions, to leave the meeting so that the examiners can ask a few questions in closed door setting. Okay. So to begin with, are there any questions from the audience?
It is very clear, sir, because he has explained it very nicely. So, congratulations, Sudeepa.
thank you, ma'am.
Don't congratulate her yet, because we haven't yet decided whether to pass her or fail her. So I mean, but if there are no questions from the audience, thank you very much for attending the dissertation defense. I'm grateful for you having to spend time on a Saturday, and if that's about it, I would ask the audience, except the examiners and the supervisors, to leave the meeting. Thank you.
Thank you, everybody, for joining. It was indeed my pleasure to share my work with all of you. Thank you, everybody, for joining.
Vandana, can you leave, please? Sorry. Sudeepa, you can remove her, no? Right. Okay. All right. Great. So, Sudeepa, before
Yes,
I forget, I just need two things from you. One is that the recording of this presentation, and second is you must also be having a list of participants, right, that you will receive after the meeting gets over. So these two things I will need from you.
Okay, sir.
Okay. All right. Professor Saha, questions?
Yeah. So thank you, Sudeepa. I really enjoyed your talk. Yeah, and it was a very nice presentation, and all the concepts you have explained in detail. And I really liked the presentation and also the work that you have carried out as a part of your thesis. So
Thank you.
mostly, but the works that you have carried out are clear to me. So I just have a few queries, and you also published in good journals and the conferences like this A category A conferences and Q1, Q2 journals. So there is not much to ask. But just one point, like H index also counts. Like, what is the definition of H index? That how many papers are cited? Like, if my H index is 30, that means I have minimum 30 papers which are cited at least 30 times.
Yes.
Yeah. So that measurement are you doing in the Alice or etc. Like, I understand your that approach that you are counting self citations, then how many citations are done by my neighbors, like community, then genealogical citations. Those all three factors are very interesting. But my point is that suppose I am one of my paper got very high citation, but others papers are not well cited. In
Yes, ma'am.
that case, will there be any effect in the Alice measurement?
Ma'am, that is what the problem is with H index. What happens is, let's say I have a paper which is really which is very good work and has got 50 citations, but I only have 4 publications. So even if one of my papers has 50 citations and it has all the citations coming from outside my community and genealogy, I will still be given a H index of 4.
Okay.
Right?
You want to
But
remove that drawback?
yeah,
I
I
mean,
want to
I mean,
remove that
I mean,
drawback.
if I may elaborate on this. So, when you look at Alice, you can look at Alice in two different strata of researchers. So, if it is aimed for researchers, early career researchers, like people who are within 5 years of their PhD, right? So that is a particularly helpful metric, much more useful than H index. But if you look at experienced researchers, so for as far as Alice is concerned, we cannot define something in the same way as H index, but we can do that for what Sriparna you are asking. We can do that for NCC. We can do that for NCC as well as NGC in the same way as H index. But Alice we can't, because the way the model is defined, the values of the output response variable is always between 0 and 1. So so we can't do that exactly for Alice, but for the input parameters of Alice, if we define each one of them as an index, we can definitely do something very similar to how H index is calculated.
Yeah, so the main core thing is that if suppose the researcher is well cited by other researchers, not from the community or not from the genealogy, and then the H index would be obviously high. In that case, Alice will also give you a very high value. No, that is the kind of a correlation can we establish?
No,
Like this
actually there is no.
Bhuya's example that you have cited.
No, there
That
is no
Bhuya,
correlation. Sriparna, there is no correlation.
yeah.
If your self-citation count and the citations that you receive from your co-author network and genealogy network, if that if that constitutes a significant chunk of your total citations, then your Alice score will actually be on the lower side.
Lower side.
Yeah, now I am asking that no, if that is very low, like my self citations, community citations, genealogical citations are
Yes.
very
Yeah,
less.
yeah, yeah,
In
yeah,
that case,
yeah.
age time,
That
like Bhuya's example you have shown, na
Yeah.
Bhuya, that he is
Yeah.
having a very good
Yes.
H5 index as well
right.
as good
So,
Alice
ma'am,
index.
for this, you will be considered as a celebrity author. Sorry, sir, I'm interrupting in between.
No, it's okay. It's
Yeah.
your thesis.
So, in that case, yours is celebrity author status. Like we saw for Bhuya, Rajkumar Bhuya, He
Yeah, of course,
has
yeah.
extremely good publications, and we are our model doesn't define. We are not defying that. We are giving credit to him because he has, because of the, not only because of the number of publications, but we have also gone ahead and see the citations. He actually is globally influential, and we have seen that he is even not only epidemic, he is endemic. Means now if he reduces the rate of publications, his influence will always remain in the domain.
Okay.
So people
Mhm.
who
No,
want to
I know,
work
I
in
know.
cloud
But what
will go
Suparna
and
was asking, is a specific question. What she was asking is that if somebody has high NCC, high NGC, and high OCQ, then that person's ALICE will also be high. So the answer is yes.
yes,
Yes. And
yes.
there is not a direct linear correlation, Sriparna, but there is a non-linear relationship between that response variable and these input parameters.
Yes.
Okay, and just one just one question
Yes,
out
ma'am,
of
please.
curiosity. So,
Yeah,
do
ma'am.
you think that where the researcher is publishing papers, the venue is also important? Like suppose I am publishing in some high top tier venues and also some low, like some mediocre venues. So, like citation is obviously if I am publishing in good venues, then citations would be high. But otherwise, is there any way is there any process of considering this factor
I
as
mean,
well?
yes, if I may answer that, Suparna, it's a very good point. But in the present framework, we have not accommodated it. If we have
Yeah.
to accommodate it, like, and in fact, that was a separate paper that I wrote with some other people using a delay differential equation based modeling, where we use the journal reputation as
Mhm.
an external control variable. That can
Yes.
be done. That can be done, but not done in her work.
In our work. Yes. Yes. Yeah.
Yeah.
Yeah. Otherwise, Sudeepa, thank you. Very nice presentation. Yes. Yeah. It was a very nice work, and keep it up. And yes,
Thank
I'm done.
Okay, so Professor Dayasagar and Professor Saha, I will send you a few documents to sign.
Yeah.
Okay,
Yeah. And
so
Hatias, so then we can officially declare like Dr.
uh,
Sudeepa.
let's that is up to you.
That should be
If you
declared by
decide
the
to,
external examiner.
Okay.
And
yes,
I
yes,
think
yes.
let Sriparna just announce. Let her put the last words
Yes,
for
yes.
Sudeepa.
So it's up to you actually, Suparna. So
Yeah, I'm in home. Sorry, I don't know whether should I. Yeah. So yes, Sudeepa, many thanks for this nice presentation and for this nice work. And you have good publications in this Q1, Q2 journals and also in top A conferences. So it is indeed a very elaborated work. And heartiest congratulations for your this doctoral degree. And
thank
yes,
you.
so now we can call you Dr. Sudeepa Roy Dey.
okay, all right.
Thank you. Thank you
Okay,
so much.
all right,
Thank you,
all right.
ma'am, for
Congratulations.
joining.
Yeah,
Yeah.
congratulations, Sudeepa. I think you should
Thank
thank
you, sir.
Suparna especially because she was
Yes.
she was not well actually.
Oh,
Well, for
okay.
several
Thank
days.
you so much, ma'am, for joining. And
That
thank you so much
she
for,
was also
No,
slightly.
attending.
it's always a pleasure to listen Dr. Saha's students, you know.
Well, I'm
You
glad to
will
say
you will get
because
you will get many new
because
concepts in your mind, many mathematical formulations, power law, what else this oh my god.
I think sir had so much of, there was so much of input from sir that we could, whatever we achieved is because of sir. Thank you so much,
So
sir.
interdisciplinary, you know the term
anyway, Sudeepa,
interdisciplinary
you have
researcher.
so
So
actually,
interdisciplinary researcher, so now we have to modify this terminology, interdisciplinary researcher. So you have to give the example of Snehangshu Shaha. So what do you mean by
according to
interdisciplinary research?
okay. I mean, see, the thing is, Sudeepa, you have passed. It seems because from the external examiner's comment, it seems that you have passed. So, congratulations.
Thank you, sir.
Something done despite being a part-time PhD student, which is hard, right? And despite being in a general environment which is not very supportive, I mean, you have done very, very well. And I'm really